All right, we're gonna get started here. Let me think. Can you? Is it okay? The volume a little bit louder. All right. Good morning. We're gonna get started here. Thank you for joining. Thank you for listening. Welcome to CVPR. I'm Kellen Cartledge. I'm a senior solutions architect with Miris. And with me is Joe Nordling, one of our senior applied researchers. Thank you. In March, Miris and Voxel 51 announced a partnership to close the last mile gap for physical AI teams. Today we're here to show you the results of that partnership, which is Miris Spatial Streams now native in the FiftyOne platform. So this morning we'll walk you through why that matters, what spatial streaming is, and then we'll walk you through a sample use case showing automated 3D annotation that you can get started with today. So physical AI teams like yourself maybe don't lack spatial data. They lack a practical way to work with that data and to visualize that data. Of that data, that content is ready to work with. The tools to curate it are like FiftyOne are ready, but the path from data to content that you can visualize, inspect, and act on still has a lot of friction. So today there are really two options when it comes to working with and delivering 3D data at scale. Option one is you download everything. Your users pull multi-gigabyte 3D files to their workstation with a discrete NVIDIA GPU before they can even look at any of that data. Sharing this data means shipping files, shipping multi-gigabyte files. Scaling with means spending cycles, optimizing and compressing your data. Option two is pixel streaming. Many people are familiar with pixel streaming, but it's the process of rendering on a cloud GPU and sending those pixels to your user screens. And this process, pixel streaming, it works, but not at scale. So with pixel streaming at scale, every user requires their own GPU, which means costs scale exponentially and latency degrades over distance. And really, the fundamental issue here is that neither distribution method was designed to deliver high-fidelity photorealistic 3D at internet scale. And that's the gap that Miris and Voxel 51 are working together to solve. So diving into Miris a little bit and how we work, Miris solves this problem the same way that Netflix or YouTube solved it for 2D video, except we do it with 3D space. So we stream full fidelity, photorealistic spatial content directly to the browser and provide progressive refinement so that you get an instant preview that sharpens to full quality in milliseconds. And it's really a fundamentally different architecture than the other two distribution methods that I spoke about a second ago. Miris transmits spatial data and not pixels. So because of that, there's no requirement for per user GPUs, and our infrastructure scales more like a content delivery network that you're familiar with today. And this is really where Miris and the Voxel 51 partnership come together. Miris handles this delivery, photorealistic spatial content, progressive refinement, and serverless infrastructure. 51 handles what it's always been best at, data curation, annotation, and model evaluation. With Miris 3D streaming in FiftyOne, all you have to do is update your 51 build to the latest today, drop in your Miris viewer key, and any Miris conditioned 3D asset that you have will stream directly into 51 and take advantage of 51's built-in tooling for labeling, annotation, and metadata. Also, we're shipping a Miris plugin for 51. The plugin packages a sample workflow showing integration end to end, so you can get started without writing any custom code. And Joe's going to walk through what that is here. So, all right, you take that.
This one.
Take that. Take that.
Yep.
All right, we got to swap a little bit.
Awesome. So like Kellen just said, our main architectural advantage is that we deliver spatial data, not pixels. And so this is what makes us fundamentally different from pixel streaming, is that with the full fidelity asset on device, you can render from any angle and you can annotate in 3D, which is what we integrated with 51. And what allows us to do this is our field-based representation. And so we're taking advantage of the latest work in radiance fields in order to enable this progressive refinement that adapts to the device capabilities, the network conditions, specific content characteristics, as well as how users commonly interact with that specific piece of content. Our Miris WASM engine runs in any browser with an internet connection, and so you can deliver and view your high fidelity content, whether it's within a website or within 51 or one of the other many platforms that we support. And so, yeah, like Kellen mentioned, the infrastructure is CDN-like, so we scale with no cloud GPU costs. Moving into what we did with 51, we added the Miris stream node as a native type within 51, so it sits alongside your other 3D formats like PLY, GLTF, OBJ, and is treated just like any of those assets, even though there's no content actually on device when you open the stream. And so when the 51 scene graph comes across a Miris asset, it boots up our runtime, uses our render to then adaptively stream the content to the viewer. And this is all happening through our SDK. And so what this allows us to do is take advantage of all the benefits that 51 has with annotation. And like Kellen said, our plugin ships with some sample workflows of how to use our spatial data within 51. The first example of that is to actually pull all your Miris assets down into a 51 data set. You could do this by hand, but it's a little tedious. Our operator in our plugin does it automatically for you. The second thing, which is what I'll be talking through next, is a automated segmentation workflow in 3D. After this talk, we have a live demo back over here in the booth that we're showing people how it works. So definitely stop by after that and ask questions. But we basically take our Miris stream on device. We can render lots of different viewpoints of that stream, feed those viewpoints to the foundational models that all of you are familiar with for your traditional 2D segmentation. We then project those predictions back into 3D space, and you can visualize those automatically within the 51 browser. So let's see it in action. So here you'll see some of our Miris data sets. This is like a physical robotic manipulation data set where we have a table and maybe we want to pick up an iPad or move an orange, something like that. And so right now it's just like an unlabeled Miris stream. We place those cameras along the waypoints. And so these are where the cameras are going to be placed to actually generate the data to feed into our models. And then we get these very, very nice bounding boxes. And because this is all done within 51, you can annotate, relabel, redraw any of these that maybe a model missed using the 51 annotation tab. So we're using Dino for our open vocabulary segmentation model. So you can paste in whatever you want to segment. It'll spin up, start rendering all your frames, happens pretty fast. And then eventually, yeah, spit out your bounding boxes. So what does this really enable, right? Right now, if you have complex 3D data and you want to run near real-time segmentation or operations in 3D, you have a couple options, none of which are great. You could use a sparse point cloud, and that is, for large scenes or complex models, often too sparse to give models enough signal to actually be productive. You could use a compressed mesh, but oftentimes you get artifacting in the faces, and you need to manually clean up that work for every one of your assets. If you're scaling to thousands or hundreds of thousands of scenes, manually cleaning each one isn't very scalable. Or you could use a Miris stream, which has our process automatically adapt to whatever the content is. And this is just one of the things you could do with this plugin. And so I'll hand it back over now to Kellen to talk about some of the other use cases.
Switch back.
All right, thank you. So there are three workflows that we're targeting today that FiftyOne users can get started with by using Miris streams in FiftyOne. First is autonomous systems. Think about self-driving or robotics teams who are reconstructing urban intersections from a drive or a capture. They're now able to take that photoreal capture and review that reconstruction directly in FiftyOne. They no longer have to download a multi-gigabyte 3D file in order to do that. It streams directly into FiftyOne alongside the data sets, labels, and annotations. Our second use case is for manufacturing and defect inspection. So think about a QA team that captures high resolution 3D scans of their mechanical or industrial components, their robotic components, and they're now able to take those and stream them on demand. And in addition, switching between those 3D assets no longer takes minutes. It no longer takes opening a 3D file in a specific application. They can merely switch between them in FiftyOne and see them in milliseconds. And then finally, our third use case is automated 3D annotations that Joe just walked us through. So if you're interested in diving deeper in how Miris streaming works, how spatial streaming works, please join us back here at 3 p.m. For our technical walkthrough today and tomorrow. But we're here all weekend, so come on by and let's talk about your 3D data. Thank you.